Subsea is a term to refer to equipment, technology, and methods employed in marine biology, undersea geology, offshore oil and gas developments, underwater mining, and offshore wind power industries. Oil and gas. Oil and gas fields reside beneath many inland waters and offshore areas around the world, and in the oil and gas industry the term subsea relates to the exploration, drilling and development of oil and gas fields in underwater locations. Underwater oil field facilities are generically referred to using a subsea prefix, such as subsea well, subsea field, subsea project, and subsea development. Subsea oil field developments are usually split into shallow water and deep water categories to distinguish between the different facilities and approaches that are needed. The term shallow water or shelf is used for very shallow water depths where bottom-founded facilities like jack-up drilling rigs and fixed offshore structures can be used, and where saturation diving is feasible. Deep water is a term often used to refer to offshore projects located in water depths greater than around 600 feet, where floating drilling vessels and floating oil platforms are used, and remotely operated underwater vehicles are required as manned diving is not practical. Subsea completions can be traced back to 1943 with the Lake Erie completion at a 35-foot water depth. The well had a land-type Christmas tree that required diver intervention for installation, maintenance, and flow line connections. Shell completed its first subsea well in the Gulf of Mexico in 1961. Systems Subsea production systems can range in complexity from a single satellite well with a flowline linked to a fixed platform, FPSO or an onshore installation, to several wells on a template or clustered around a manifold, and transferring to a fixed or floating facility, or directly to an onshore installation. Subsea production systems can be used to develop reservoirs, or parts of reservoirs, which require drilling of the wells from more than one location. Deep water conditions, or even ultra-deep water conditions, can also inherently dictate development of a field by means of a subsea production system, since traditional surface facilities such as on a steel-piled jacket, might be either technically unfeasible or uneconomical due to the water depth. The development of subsea oil and gas fields requires specialized equipment. The equipment must be reliable enough to safeguard the environment and make the exploitation of the subsea hydrocarbons economically feasible. The deployment of such equipment requires specialized and expensive vessels, which need to be equipped with diving equipment for relatively shallow equipment work and robotic equipment for deeper water depths. Any requirement to repair or intervene with installed subsea equipment is thus normally very expensive. This type of expense can result in economic failure of the subsea development. Subsea technology in offshore oil and gas production is a highly specialized field of application with particular demands on engineering and simulation. Most of the new oil fields are located in deep water and are generally referred to as deep water systems. Development of these fields sets strict requirements for verification of the various systems unregistered trademark functions and their compliance with current requirements and specifications. This is because of the high costs and time involved in changing a pre-existing system due to the specialized vessels with advanced onboard equipment. A full-scale test does not provide satisfactory verification of deep water systems because the test, for practical reasons, cannot be performed under conditions identical to those under which the system will later operate. The oil industry has therefore adopted modern data technology as a tool for virtual testing of deep water systems that enables detection of costly faults at an early phase of the project. By using modern simulation tools, models of deep water systems can be set up and used to verify the system's functions and dynamic properties against various requirements specifications. This includes the model-based development of innovative high-tech plants and system solutions for the exploitation and production of energy resources in an environmentally friendly way, as well as the analysis and evaluation of the dynamic behavior of components and systems used for the production and distribution of oil and gas. Another part is the real-time virtual test of systems for subsea production, subsea drilling, supply above sea level, seismography, subsea construction equipment, and subsea process measurement and control equipment. Offshore wind power. The power transmission infrastructure for offshore wind power utilizes a variety of subsea technologies for the installation and maintenance of submarine power transmission cables and other electrical energy equipment. In addition, the monopile foundations of fixed-bottom wind turbines and the anchoring and cable structures of floating wind turbines are regularly inspected with a variety of ship and subsea technology. Underwater mining. Recent technological advancements have given rise to the use of remotely operated vehicles to collect mineral samples from prospective mine sites. Using drills and other cutting tools, the ROVs obtain samples to be analyzed for desired minerals. Once a site has been located, a mining ship or station is set up to mine the area. Remotely operated vehicles. Remotely operated vehicles are robotic pieces of equipment operated from afar to perform tasks on the sea floor. ROVs are available in a wide variety of function capabilities and complexities, from simple eyeball camera devices, to multi-appendage machines that require multiple operators to operate or fly the equipment. Organizations. A number of professional societies and trade bodies are involved with the subsea industry around the world. Such groups include Subsea Engineering Society, Society for Underwater Technology, Subsea Project Awards, Subsea UK, Subsea Valley, the largest subsea technology business cluster. Society of Petroleum Engineers, American Petroleum Institute, American Society of Mechanical Engineers, National Association of Corrosion Engineers. Government agencies administer regulations in their territorial waters around the world. Examples of such government agencies are the Minerals Management Service, Norwegian Petroleum Directorate, and Health and Safety Executive. The MMS administers the mineral resources in the U.S., and provides management of all the U.S. subsea mineral and renewable energy resources. See also, Christmas tree, list of offshore wind farms, marine engineering, ocean engineering, offshore geotechnical engineering, oil well, passive heat compensation, riserless light well intervention, submarine pipeline, subsea production system, wellhead. References